I'm Shobana, Senior Director of Engineering for TV at Google. Today, we'll dive into the latest updates from Google TV and our underlying Android TV OS and explore the ways you can build excellent TV apps. Last fall, we mentioned that Google TV and Android TV achieved over 270 million monthly active devices, establishing one of the largest smart TV OS footprints. We look forward to increasing this momentum by bringing our platform to more form factors and delivering more delightful user experiences this year. We are glad to see users interact with our platform across a diverse range of entry-level to premium devices, from TVs, phones, and tablets, to projectors, and most recently, smart monitors. We're especially proud to see support for Google TV on the awarded Omen 32X smart gaming monitor, and have our new Google TV streamer recognized as the best media streaming device by the New York Times Wirecutter. Today, we are excited to share even more ways users can access effortless entertainment on Google TV this year. First off, we'll be partnering with select OEMs to launch affordable and reliable low RAM panel TVs, allowing more budget-conscious users to experience quality entertainment. We're also excited to soon bring Google TV to headsets powered by Android XR. Users can see, hear, and explore the action from the best seat in the house. They can access their favorite content across their subscriptions, search for content, and get curated recommendations. Our broad platform availability across a variety of form factors directly translates to more opportunities for you to connect with users worldwide. To further enrich the user experience, we've brought more apps to our global platform. Just to name a few, we have launched History Vault in the US, BBC, Channel 4, ARD, TF1, and ITV in EMEA, as well as Geo Hotstar and Video in the APAC region. Now, I can watch my favorite Bollywood movies from these apps on Google TV. Our quality streaming partnerships also allow us to sustain strong app engagement. In 2024, US users spent approximately 200 minutes in apps per day. As our platform becomes even more diversified with excellent apps, we're also making improvements to help users find what to watch and offer new ways for your apps to reach your target users. Last year, we previewed the Video Discovery API that's available for partners. Video Discovery optimizes resumption, entitlements, and recommendations across all Google TV form factors to enhance the end-user experience and boost app engagement. You can now easily display a user's paused video within the Continue Watching row from the home screen. Resumption drives 60% of all user interactions on Google TV. This interface allows users to resume viewing from where they left off, across any device when they are signed in with their Google account. The Video Discovery API also streamlines entitlement management, which matches content to eligibility. This eligibility might be from a subscription, purchase, or a free ad-supported model. Video Discovery allows users to share their entitlements through one simple opt-in process. Users appreciate this because they can enjoy personalized recommendations without needing to manually update all their subscription details. This allows you, as our partners, to connect with users across multiple discovery points on Google TV. That means more immediate access and increased app engagement. The Video Discovery API even highlights personalized content recommendations based on content that users watch inside apps. Partners can begin incorporating the Video Discovery API today, starting with resumption and entitlement integrations. Check out the link for more details to enroll. Google TV is committed to responsibly using AI to bring more helpfulness into the home too. For instance, last fall, we released AI-generated content descriptions, which help users find their next favorite film or series to watch. Users can access bite-sized season summaries, learn more about a movie, and see feedback from other viewers. Google TV also offers custom AI screensavers, so users can simply use their voice to create stunning screensavers for the largest screen in their home. Earlier this year, we announced that we'll bring Gemini capabilities to Google TV, so users can speak more naturally and conversationally to find what to watch and get answers to complex questions. Our new AI assistant now understands users' natural conversational voice searches. It then analyzes titles from your apps and shares tailored recommendations, effectively boosting the visibility of your app's content. Let's dive deeper into what this looks like. For instance, I want to share my interest in the classic Jurassic Park movies with my younger kids, but I don't want to show them something too intense. Now, I can easily ask questions like, I like Jurassic Park. What are some movies like it that I can watch with my kids? And voila! I get personalized recommendations, perfect for my next family night. Plus, users can naturally ask questions to explore their latest curiosities and get insightful answers with supporting videos for deeper learning. They can invite the whole family to learn, asking questions like, can you explain the solar system to my first grader? And the AI assistant will provide a personalized response with suitable video suggestions that a first grader would be excited to see. When we demoed Google TV with Gemini at CES, we were pleased to receive the Best AI Award from Tom's Guide. We are so excited to bring this new, helpful, and delightful experience to users this fall. There's never been a better time to be a Google TV partner or developer. I'll now hand it over to Paul from our developer relations team, who will share more about Compose for TV, provide suggestions on improving your app's performance, and explore some exciting features from Android 16. Over to you, Paul.
Thanks, Shobana. Last year, we launched Compose for TV, which lets you build beautiful, adaptive UIs across Android, including Android TV OS. If your app is following best practices for adaptive apps, you've done most of the work already to adapt to TVs. Compose is also where we're continually improving the developer experience. SoundCloud built upon these improvements to overhaul their app's design system with Compose, building new features and using 45% less code on average. It took them just 4 months to build their TV app from the ground up. You can read more about their Compose journey on the Android developer blog. Compose for TV 1.0 is stable and expands on the core and material Compose libraries. The March 2025 release of Compose significantly improves app startup in our internal benchmarking sample on mobile, with roughly a 20% improvement compared with the March 2024 release. We've seen jank rates on older Pixel 3a devices reduced by up to 76%. Both of these metrics are already considerably better than Vue's performance, and on hardware-constrained devices like TVs, those enhancements are huge. Our updated Jetcaster sample demonstrates how to use Compose across form factors. It includes a dedicated module for playing podcasts on TV by combining separate view models with shared business logic. Check out the details in the Compose Tips for Delightful UI video series. We've now also updated our Jetstream sample to demonstrate how to share logic within a single module. This approach uses the most amount of code between form factors. These are 2 comprehensive samples that show how to reduce code and maintenance by building adaptive apps for Android. We've also heard your feedback about handling focus and are making iterative improvements, including our newly published Code Lab. We've seen 3 common challenges when handling focus behavior on TV. First, setting initial focus. Second, taking over control of unexpected focus traversal. And third, restoring focus. Let's explore setting initial focus. In a TV UI, whenever opening a screen, the initial focus needs to be set. Compose for TV does this in the majority of cases, but sometimes the default might differ from your preference. You can control that initial focus in 3 steps. First, declare a focus requester that's wrapped in a remember function. Then, apply a focus requester modifier on the first card. And finally, call the request focus method in the launched effects composable function. This last bit ensures that the focus is moved to the right element when the composable is composed for the first time. Now let's take a look at some scenarios where focus moves to an unexpected component. Here we have 4 items arranged in rows and columns. When I press the right D-pad button, the focus moves from the first item to the third item. That's odd. To understand why this is happening, we can look at our layout hierarchy. The 4 focus targets are at the same level, and third card is the first item to the right of first card in the layout. That's why focus moves from the first to the third with the right directional key. We can resolve this by creating a focus group that consists of the focus targets inside the row. Now, since the row and the first card are the only focus targets at the same level, pressing the right directional key no longer moves to the third card. From within a focus group, we should also make sure that focus is restored when the user returns to it. By using the focus restorer modifier, we can make sure that the focus is brought to the right element in the group. Now, these are just a few examples taken straight from our new Focus Management Code Lab. Check the video description for an entire guide. Our goal is to make this even easier, and we'll continue to improve focus behavior in Compose, so stay tuned to the Android Developer channel for updates later this year. Whether or not you're using Compose, getting optimal performance out of your TV app is always important. This is why we've published a comprehensive guide on memory optimization, including memory targets for low RAM devices. Combined with Android Studio's powerful memory profiler, this helps you understand when it exceeds those limits and why. In the worst case, if your app is using memory carelessly, Android TV OS may perform direct memory reclaim, a process that might severely disrupt your app. But more often, ineffective use of memory will trigger garbage collection in your own app, resulting in a jarring experience. I've pulled up an old Leanback app as an example of bitmap allocations and how it makes memory grow bigger than necessary. It displays a typical grid of images that are loaded dynamically, and as you can see, it does not have good performance. Let's take a peek at the code that handles displaying the poster images. It has a very straightforward approach using Glide to load images into cards. Okay, let me restart the app and start a session of a memory profiler. I'm attaching it to the app process and selecting the preset to track memory allocations. Great, it started. While I scroll on the screen, we can see how the Java memory in blue and the graphics memory in orange are growing simultaneously until a spike of memory is reached. Ooh, look at those little garbage can icons. They indicate the many times garbage collector is called. And every single time it's caused a little bit of jank in my app. Also notice how there's a spike in the memory graph before garbage collection kicked in. We want to prevent as many spikes as possible. On this low memory device, it's preferential to avoid using 2 different types of memory for images when we could mostly use graphics memory. By loading the images this way, I'm loading them into Java memory and displaying them using graphics memory, which is effectively using twice the amount. All right, back to the code. Let's change the Glide configuration to use hardware-backed bitmaps so we can transfer the bitmap directly to the graphics memory and free up our Java memory space. We'll do this by changing the request options and setting the downsampler allow hardware config to true. It'd be neater to define this in our app configuration, but just for illustration, I'm just going to drop this line right here. Let's run the app again and attach a new memory profiler session to it. Now, by doing the same type of scrolling as before, we can now observe that both types of memory do not grow simultaneously. This configuration allows for the bitmaps to be released from Java memory as they're loaded into graphics. So, in general, less memory is being consumed, and consequently, we're seeing fewer spikes. Memory also frees up sooner once we stop scrolling compared to before. I've been using a low RAM device for illustrating this optimization, and as you can see, it's essential to test your app on lower end hardware. Now, we can use this as it is, or we can set it up for only low RAM devices. On higher memory devices, we may consider allowing Glide to use its bitmap cache to rapidly display images instead of reading them from disk. After all, unused memory is wasted memory, and striking a good balance here is really the name of the game. I can call activitymanager.isLowRAMDevice to check if there is a low RAM device. I need an instance of the activity manager, and with that, I can check for the low RAM flag. Now, let me move that glide configuration inside the condition, and we're good to go. Using Compose in combination with Coil's async image provides these kinds of memory optimizations out of the box, but you should still be vigilant about memory consumption. For example, if you're loading bitmaps into a painter instead of directly into a composable, Coil will not be able to detect how large it needs to be on the screen, and it'll always load the image with its original dimensions. You might also benefit from deliberately downsampling images on low RAM devices by specifying a size modifier like I've done here. This only scratches the surface, so check the guide for more details about optimizing for memory. The guide also covers recommendations for reducing memory overhead when working with graphics, media, and bindings. Examples include performing image composition off the device and allocating the video seek buffer. We're excited to announce the upcoming release of Android 16 for TV. Developers can begin using the latest beta today. Android 16 includes some great features to help TV developers. First, the new Media Quality API provides a standardized interface to developers and vendors to manage picture profiles. For movies and TV series that are mastered with a wider dynamic range, developers might request Filmmaker mode to accurately display content as the creator intended for it to look. A cinema profile with greater color accuracy brings out subtle details and shadows in favor of increasing brightness. Conversely, live sporting events, which are often mastered with a narrow dynamic range and watched in daylight, can benefit from a profile that gives preference to brightness over color accuracy. If you'd like to understand which profile a device running Android 16 or later supports, query Media Quality Manager using GetAvailable Picture Profiles. The profile ID may match against a known system profile, some of which may differ by OEM. To apply a specific profile, you can query Media Quality Manager by profile ID, for example, for this one, for cinema profile. You can then apply this picture profile as a parameter to media codec by providing in a parcelable into its bundle. Selecting a picture profile in Exoplayer will be available in a future release later this year. You can find the list of predefined profiles in the updated guide for adjusting a display settings. Note that these presets aren't fixed. TVs come with some preset profiles, but OEMs can include more and users can update them based on their preferences. Another new feature in Android 16 is platform support for Eclipsa Audio. This is a new open-source spatial audio codec based on the immersive audio model and formats developed by Google, Samsung, and other key contributors within the Alliance for Open Media. It's designed to revolutionize immersive audio experiences across a wide range of applications, including streaming and gaming in augmented or virtual reality. And because the format is open source, anyone can use freely available audio tools or leverage automated workflows that use FFmpeg to create Eclipsa audio files. You can already begin using these codecs today, even on older platforms, by using the built-in support in Media 3 Exoplayer from version 1.5. By compiling the libiamf library, you'll get a dedicated audio renderer instance. For details on how to compile it, see the decoder extension guide on GitHub. Android 16 for TV now supports 64-bit kernels, which means you can run the emulator natively on a 64-bit host machine. Although there aren't any 64-bit Android TV devices yet, it shows how we're laying the engineering framework. We recommend that you also begin preparing your TV apps for 64-bit compatibility, just like you have been doing for other Android form factors. But it's important to continue supporting 32-bit platforms for many years to come, and remember that you can use app bundles to minimize your application size by supporting both. Finally, let's explore some more areas where developing for Android tvOS brings consistency and delightful experiences across Android. Let's start by taking a closer look at content discovery. If you're a seasoned Android developer for Android tvOS, the Continue Watching row probably sounds familiar, and perhaps you struggle to implement it because the Watch Next API is transactional, requiring persistent client-side IDs. You can now use the greatly simplified Video Discovery API, which Shobana showed us earlier. Since this API is powered by the Engage SDK, it's simultaneously preparing your content for more surfaces, like the recommendation row, and across other Android-powered devices. First, we'll discover if this API is available, depending on your participation in the program. Learn more about enrolling at the end of the session. For the code in the next sections, let's assume that we've checked it's available by calling isServiceAvailable. When using the Video Discovery API, creating content entity types is very similar, and you can collect them into a continuation cluster. And here's the neat thing. Whenever you want to update each entity in the cluster, all you need to do is submit the entire cluster with a single call to publish continuation cluster. We've heard your feedback. You don't have to provide insertions, updates, or removals to individual entities anymore. To support device entitlements, as Shobana showed earlier, you can associate multiple account profiles to enable a personalized continue watching experience. You can do this by providing a record through set account profile. And after getting user consent, your app can then share the user's data across all of their devices by calling set sync across devices with true. This is a phenomenal way to keep your content recommendations in sync as users watch your app's content on different devices. Like Shobana said, this API is not just for TV either. You can use the appropriate Engage SDK libraries for other form factors. And as a reminder, if you're not enrolled in the Video Discovery API program and are interested in joining, head over to this short link to fill out the form. Last year, we showed a sneak preview of the in-app ratings and reviews prompt for TV. I'm happy to announce that the in-app ratings and reviews API is available for all TV developers. By implementing the same PlayCore API you know and love on mobile, you can convert delightful moments in your TV app into a higher app rating on Google Play. For more details, read the blog post that's linked in the video description. As you can see, these updates bring consistency to app development across Android, making it easier than ever for developers like you to build apps that work across all form factors and engage with users through consistent APIs and surfaces. We're excited to see the immersive, engaging experiences that you create.